G1, before we continue with the class, I had a question
Yes.
regarding to Colab. Is it just for Python code, or does it work for any other kind of programming languages?
Uh, for me, I only use Python on Colab,
Okay.
so yeah. I didn't
Yeah,
try other languages, but
it's
yeah.
because I tried to like type some Java syntaxes, but it seems like it doesn't work.
Yeah, I think because it is a machine learning website,
Okay.
and
Okay.
on the machine learning part, we almost most of the people use Python, so I think Java code will not run on the Colab.
Okay.
Yeah,
Okay. Thank you.
great. So,
Recording in progress.
asking again, have you guys set up the, if you guys have set up the dataset, please give me a thumbs up. Thank you.
Chicos, recuerden enviar el pulgar arriba si ya lograron cargar el dataset.
Chicos, en el chat también, Ujiwon les se está compartiendo el material de la clase, entonces para que lo descarguen.
Okay. Uh, uh, we have limited time, so we need to continue. And those who couldn't import the dataset or something, it's totally fine. We made the workbook and also the presentation. We have sent you the file. So later, like after class, you could try again. So yeah, it's totally fine. For those who couldn't import the dataset today, just watch and just think that these kind of things are here. Yeah, those kind of things. So
All right.
moving on. Uh, so we load the data, and for the next one, we're gonna look about the data frames of pandas. So we can use the dtype attribute to display the data types of each column in the data frame. So this is important because it helps us understand what kind of data we're dealing with. For example, some columns might contain numerical data, while others might contain categorical data. So knowing the data types help us decide how to process and analyze the data. So you guys can see that we could know the data types of the features of the columns. Okay, this is short, so moving on. And as we did, uh, as we did before, uh, the head function, when we use with an argument, allows to specify how many rows we want to display. So in this example, head 10 displays the first 10 rows of the dataset. So as we saw seen before, like this, it only shows the 5 rows of the dataset. But if we put 10 in it, it shows the 10 rows of the dataset. So, like I said, this is useful for getting a large sample of data to understand its contents better. Moving on. And next are columns. We can add new columns to a data frame to create derived features based on existing columns. So this example, we're creating a new column called the family size by adding the values of the sibling and parse columns and adding 1. This new feature can help us analyze by giving us more information about each passenger's family sizes. So please code. And for now, please give me a thumbs up if you guys are done. Thank you. Okay, moving on. And also, indexing columns and filtering rows are powerful features of Pandas that help us to extract specific parts of the data for analysis. So in the example shown, we are accessing specific columns using the select columns and filtering rows based on a condition using survivors. So this allows us to focus on data that is most relevant to our analysis. Also, please code and give us thumbs up. Thank you. Okay, moving on. So next one is handling the missing datas. So handling missing datas is a crucial step in data pre-processing. So we use the isNull.sum function to identify missing values in our dataset. This function returns the number of the missing values in each column, helping us understand the extent of the missing data problem. So please code. Also give me a thumbs up if you're done. Okay, moving on. So we now know that these are the missing datas from our data. So to handle these missing values, we can use the fill function. This function allows us to fill missing values with a specified value, such as the means for numerical columns or the mode for categorical columns. We can also drop columns on rows with too many missing values using the drop function, and this helps clean the data and make it ready for the analysis. Jesse, dice?
Yeah, I only have
Yes.
one question is how like the function know what is the value that need to fill.
Uh, Sorry, can you say that again? Sorry.
Okay, how the function like fill now
Yes.
can like predict the value of fill the missing value
Yes.
or normally they delete this. I don't know if
Oh,
you
can
can
you write it?
understand. Okay, okay,
Oh,
okay,
can you write it on chat? Thank you.
okay.
He said that uh, how does the function fill missing values knows what is the value to use on the empty field.
Uh, for me, I know. Uh, for the cabin that which was the missing value, we just drop it. We just deleted the missing values, and filling those values. Kind of, I know that just filling with the uh. How does the filling function knows what the value is? Ah, Uh, I don't really like knows about how does it works, but I just know that we use the fill function to fill the missing data and handle the missing data. Yeah, so if you want to know how does it works, then I think you should check the Python official document, I guess. Yeah. Sorry about that.
No problem. Thank you.
Okay. And if you guys are ready, please give a thumbs up. Thank you. Okay, moving on. And let's go to the describe function. The describe function provides summary statistics for numerical columns in the dataset. So this includes the count, mean, standard deviation, minimum and maximum values, as well as the 10th, 50th, and 75 percentiles. And these statistics, give us a quick overview on the data and help to identify the anomalous and the patterns. Also code, and also if you're ready, just give us thumbs up. Thank you. Okay, moving on. And grouping data and using the aggregation functions like mean help us to analyze relationship within the data. So in this example, we're calculating the survival rate by class using the group by function. And this helps us to understand how different classes of passengers had different survival rates, providing valuable insights into the data. Okay, moving on. And filtering data based on conditions allows us to focus on specific subsets on the data. So in this example, we are filtering passengers who are paid a fare greater than 50. So this helps us to analyze the characteristics and outcomes of the specific group within the dataset, making our analysis more targeted and meaningful. Also, if you guys are ready, please give a thumbs up. Thank you. Okay. So now let's move on to Matplotlib library. Matplotlib library is a powerful library in Python used for data visualization. So it helps us create different types of plots to represent data visually. We're going to use three main types of plots we can create with Matplotlib: the line plot, the histogram, and the scatter plot. First, we need to import the matplot library like this. So we are importing the matplot library .pyplot and named as plt because typing these all is kind of long, so we are shortening the library. So please import the library, and if you guys are ready, please give a thumbs up. Okay. So let's create a line plot using matplot library. We use a plt.plot function, which is the plot function, to create the plot. We also add the title and the labels to the x and y axis to make the plot easy to understand. The plot.show function displays the plot. So line plot help us to visualize trends and patterns over a range of values. So if you write the code and if you run the code, you can see the line plot graph under the code cell. Yeah. Great. Wait a minute. Yeah, it's working well. Great. Okay, moving on. Next, let's create a histogram. A histogram shows the distribution of a single variable. So in this example, we're plotting the distribution of ages from the Titanic dataset. We use the hist function to create the histogram. The bin parameter specifies the number of the bins, and the edge color adds a border to each bars. So using the show function, as we used before, the show function displays the histogram, and through the histograms, we could see how many passengers fall into different age ranges. Also, please code. Okay, if you guys are ready, please give a thumbs up. Thank you. Great. Moving on to the next one. So now we're going to create a scatter plot. A scatter plot shows the relationship between the two numerical variables. Sorry. In this example, we're plotting age against fare from the Titanic dataset. So we use the scatter function to create the plot. And the alpha parameter makes the points slightly transparent, so overlapping points are easier to see. So using the show function, we could display the scatter plot, and scatter plot help us to see if there is any correlation between the two variables. So the difference between the line plot is that we couldn't see the back side of it, but from the scatter plot, we could see the overlapping points from it, like this. So also code. Okay, moving on. Now moving on to Seaborn. Seaborn is another powerful data visualization library in Python. So it is built on the top of Matplot library and provides a high-level interface for creating attractive and informative statistical graphics. So one of key features in Seaborn is the heat map, which visualizes data in a matrix form and is useful for correlation metrics. So to start using Seaborn, we need to import it into our Python environment. We do this by writing import Seaborn as SNS. So this command imports the Seaborn library and gives it a shorter name, SNS, so it's easier to use. Okay, this is a short one, so moving on. Now let's create a count plot using Seaborn. A count plot shows the frequency of categorical variables. So in this example, we're plotting a number of survivors versus non-survivors from the Titanic dataset. We use the count plot function to create the plot. The x parameter specifies the column to plot, and the data parameter specifies the dataset. So also using the show function, we could display the count plot. And count plot are great for visualizing the distribution of categorical in the dataset. If you have issues with the camera, it's totally fine. And if you're done, please give a thumbs up. Thank you. Okay, moving on. Finally, let's create a heat map using Seaborn. A heat map displays the correlation between different numerical features in the dataset. So in this example, we're plotting the correlation matrix of the Titanic dataset. We use the heat map function to create the heat map. And the ANOT parameter adds the correlation values to each cell, and CMap specifies the color map. And also, using the show function, we can display the heat map, and heat map help us to see the relationships between variables at a glance. Okay, if you guys are ready, just give a thumbs up. Thank you.
Do you want?
Yes.
One question. So in this particular graph that we see here, what are we exactly comparing?
We can see the relationship between the variables. For example, we have like passenger IDs, the ride, P class, or these kinds of variables. So we could see the relationship between these variables. So
Okay.
yeah, actually, yeah. When we make real data, you don't actually use like heat maps, but sometimes like those like data scientists will use, but I don't know the meanings of it, but just knowing that it could see the relations between the variables. Yeah.
Yeah, makes sense. Thanks.
Yeah. Great. Yes. Okay, moving on. So now let's move on to preparing the data for machine learning. So my plan was to making a new file, but we will spend too much time on importing the datasets, so we'll just continue on this file. So data preprocessing is an essential step before training any machine learning models. So it involves preparing and cleaning the dataset to ensure the model can learn effectively. The process generally includes handling missing values, encoding categorical data, scaling features, and splitting the data into training and test sets. Proper data preprocessing can significantly improve the accuracy and performance of your machine learning model. So, when working with datasets, you will often encounter missing values, as we did before. So these can be a problematic for machine learning models to train. So to handle missing values, you can use various strategies such as filling them with the mean, median, or mode of the columns, or even dropping the columns of rows with too many missing values, as we did before. So ensuring no missing value remains is crucial for the stability and accuracy of the model. So you guys don't need to do this because you did it before. Moving on. So let's go on to label encoding and one-hot encoding. Categorical data needs to be converted into a numerical format to be used by the machine learning models. So for this, there are two common techniques, label encoding and one-hot encoding. Label encoding assigns a unique integer to each category, which is useful for ordinal data, like this. And one-hot encoding creates a new binary columns for each category, suitable for nominal data where categories do not have an inherent order. So using these techniques help models understand and process categorical data effectively. So in this example, we are applying one-hot encoding to the sex and embarked columns of the Titanic dataset. So this process converts the categorical variables into binary columns, making them suitable for machine learning algorithms. We use the getDummy function to perform this transformation, and then display the first few rows to observe the changes. Okay, if you guys are ready, please give a thumbs up again. Thank you.
마이크 안 켜져 있다. 마이크 안 켜져 있다.
What the? Sorry, my mic was off. Thank you. Now let's move on feature scaling. So feature scaling is the process of normalizing the range of independent variables on features of data. So there are two main methods, normalization and standardization. Normalization scales the data to a range of 0 to 1, while standardization scales the data to have a mean of 0 and a standard deviation of 1. So scaling is crucial because many machine learning algorithms perform better when the numerical attributes are scaled. Like for example, if we have a test with if we have two people, like one has a 100 in a 100 and the other one has a 100 in 1,000, then this could be not the same. So we need to scale the features to make the machine learning model to understand it easier. So here we demonstrate the standardization of the age and fare columns in the Titanic dataset. So like I said, standardization adjusts the values so that they have a mean of 0 and a standard deviation of 1. So this process is essential for algorithms like support vector machine and k-nearest neighbors. So we use the standard Scala from the scikit-learn library to perform this operation and then display the transformed data. Yes. And if you guys run the code, you can see that the age and fair is scaled by the standardization. And if you guys are ready, please give a thumbs up. Thank you. Okay, moving on. And to evaluate the performance of the machine learning model, it is important to split the dataset into training and test sets. Some of you who are interested in AI will know about Kaggle. And if you guys go into competitions, sometimes the data sets are separated with training data and test data, but not all are separated. So using the train test split function from scikit-learn, we could easily separate the datas. So here, we split the data into 80% of the training data and 20% into test sets, ensuring that the models can be properly evaluated on unseen data. So we have only one data called the train. So we are just splitting those data with the training and the test one, because we don't have additional test sets. So you could see that if you run the code, you can see that the data are divided into two. If you're done, also give us thumbs up. Thank you. Okay, moving on. Now we prepare the data sets. We're gonna evaluate the model and improve the model. So also passing. So now let's talk about model evaluation. After we train the machine learning model, we need to evaluate its performance to see if it works well. we can use different metrics and techniques to check if our model predictions are good or bad. So this helps us understand the model's strengths and weakness. So in order to evaluate our machine learning models, we use several key metrics. Accuracy measures the ratio of correctly predicted observations to the total observations, giving us general ideas of how well our model performs. And precision calculates the ratio of correctly predicted positive observations to the total predicted positives, indicating how many of the predicted positives are actually corrected. And recall, also known as the sensitivity, is the ratio of correctly predicted positive observations to all observations in the actual class, showing how well the model captures an actual positives. The F1 score is the weighted average of precision and recall, providing a balance between the two metrics. And finally, the confusion matrix is a table that describes the performance of the classification model by showing the true positives, true negatives, and false negatives. And these metrics together give us a comprehensive understanding of our model's performance and help us identify areas for improvement. So for me, I think you guys don't need to understand this mathematical things. Just know that there are types of evaluation like this. So we need to evaluate the model, but I think there's some libraries that you need to add. Just a moment. So I prepared this code at wait a minute. So you need to first code this cell, only this cell. Yeah. Please write this one, only this one. And if you're ready, please give us thumbs up at the chat. Thank you. So a little bit of explanation. I actually prepared this file at the Google Classroom because this is the same as we did it previously. So not making you guys do the same thing. Yeah. So if you wrote this 4 codes already, please give us thumbs up. Thank you. Yeah, right. It was the one of the files that I uploaded at the Google Classroom. For those who haven't done yet, I'll just copy and paste here. And next, you need to type this code. So we're evaluating a logistic regression model using the Titanic dataset. So first we train the model using the training data, then we make predictions on the test data. And finally, we evaluate the metrics to measure the model's performance, such as accuracy, precision, precision, recall, F1 score, and the confusion matrix. And this helps us understand how well our model can predict survival on the Titanic. So please code. We are almost there. We have only 7 slides left. If you guys are ready, please give a thumbs up. Thank you. I think it will take long, so I'll just copy and paste the code on the chat. We have only 2 minutes left, so if you copy and paste and run the code, then you will see a result like this. So this is the evaluation results for our logistic regression model. The accuracy is around 81%, which means 81% of the predictions are correct. And precision, recall, and F1 score provides more insight into the model's performance for each class. And the confusion matrix shows how many predictions were true positives, true negative, and false negatives. So these results help us to understand the strengths and weakness of our model. And moving on to cross-validation. Cross-validation is a technique used to assess how well our machine learning model performs. It helps us understand if our model will do well or unseen data. Imagine you're baking some cookies and you want to know if they taste good. Instead of asking just one friend to try them, you ask 5 of the friends to try a few cookies each. And each friend will give you their opinion. And then you average their opinion to decide if your cookie is good or bad. So this way, cross-validation helps us to ensure that our model is not just good at predicting the data it was trained, but can also perform well on new unseen data. So it's as similar as cross-checking. So I have written down several cross-validation techniques in the workbook, but among them I will introduce the k-fold cross-validation, which is frequently used. So in k-fold cross-validation, we split the data set into k equal parts of the folds. So for example, let's say we choose 5 folds. We train our model on 4 folds and test it on the remaining fold. We repeat this process 5 times, which is k times, each time using a